Thank you. Moving ahead, we have a keynote session on the topic Cloud Resilience, crafting systems that thrive in uncertainty. We have Parna Mehta, who will share how to design cloud systems that remain robust and resilient even in uncertain environment. Parna Mehta, Cloud Support Engineer, AWS. Parna, can we have you on stage, please? Parna, can we have you on stage, please? Okay. Please join hands together and welcome Parna Mehta.
Is it the green one? The green one? Yeah, okay. All right, everybody. Are you ready? Everybody's had lunch and everybody's really sleepy. I'm here to wake you up. Are you ready? I want a yes. Yeah? Yeah? Louder? All right. All right. A very warm welcome to my session on cloud resilience. My name is Parna Mehta. I'm a cloud support engineer at AWS, and I'm going to be presenting my tech talk on building systems that thrive in uncertain situations. So let's begin. Doesn't want me to begin. Excuse me. It's not moving. Yeah, forward. Green. This one, okay. All right. Without much ado, a very famous quote by our CTO: everything fails all the time. Now imagine a world where your business never sleeps. 24/7, data is accessible, your systems are up and running. Wait, did I say imagine? That is but expected. This is not a luxury. In today's world, few seconds of downtime can cost organizations millions. It can disrupt systems, it can cause damage to reputation, especially in industries like healthcare and financial services. Nothing of this sort can be tolerated. Let's take, for instance, in the aviation industry. About 2 years ago, December of 2022, peak Christmas time holiday season, a very large and popular airline had an operational meltdown. Their crew scheduling system was overwhelmed and it crashed. Imagine the scale of disruption. Over 17,000 flights got delayed and cancelled. More than 2 million passengers were inconvenienced. They learned it the hard way and they eventually moved to cloud. Take, for instance, in the healthcare industry. Last year, a very famous and premier medical institute, they suffered a system downtime which lasted for over 12 hours. Administration blamed it on routine system downtime, but it was a matter of life and death, right? There was outpatient department, emergency department which were delayed. The medics could not have access to patient data and hospital reports. Would you go under the knife of a surgeon who has no data of you? Not at all. I wouldn't go, right? And earlier to that, they even had a cybersecurity attack that wiped out hospital data and confidential billing and transaction data of patients. That lasted almost a month. Now take, for instance, in the banking and financial service industry. Earlier this year, 4 major large UK banks, they also suffered a digital meltdown. Their online systems, their mobile banking systems, there was a lot of delay in payment processing. Customers were inconvenienced. They could not access their funds, and on a crucial day like payday, I'm sure all of you know that, on the crucial day like payday, on your salary day, if you don't have access to your salary, what could be your reaction? And then finally, how many of you saw the blue screen? Show of hands. I surely did. Right? So everybody knows about this one. And what was the problem here? Because there was a faulty software update that caused disruption across industries. I'm sure you must have seen this image splashed all over your social media, right? Whoever thought that we would go back to pen and paper-based boarding passes, and from our meeting rooms, we had whiteboards coming into our airports. This is the scale of disruption that is caused. Now, what is resilience? Anybody? What is resilience? It is our ability to bounce back. Now, when we tie it down to IT, it is the ability of your systems to recover from infrastructure failure or system disruptions. It is also the ability of your applications to scale from, say, hundreds to thousands to tens and thousands of users. Now, what happens when this promise of cloud resilience does not happen? Somebody has to pay the price, right? Who pays the price? Anybody? Who pays the price? End user? Absolutely right. End user plus the business. So there are three types of impacts which will happen over here. The first is the business impact. So obviously, your customers are going to have a terrible experience. So they are going to have a negative impact. There's going to be customer churn, as we say. There's going to be financial impact. You're going to lose millions of dollars. That every second counts. Transactions lost, data lost, and there's always a cost to even repairing systems, right? Nobody accounts for that part of it. As per your customers, like you said, the end users are going to have a bad experience in terms of unpredictable, inconsistent, or they'll have huge delays in terms of response times. Now, why are we so concerned about this? Okay, why are we talking about resilience? Because as per IDC, the Fortune 1000 companies suffer anywhere between 1.25 billion to 2.5 billion in losses due to system downtime. That's huge, right? And customers who are relying on these systems and they're expecting it to be available all the time, they have a negative impact. Now, in this world of digital age, where customer expectations have risen, they are of a mindset that the services should be available up and running all the time, 24/7. That's completely changed. For instance, think about it, when mobile phones came into the picture, right? Some of you were not even born then, I guess. So when the mobile phones came in, if we had network in just one room of our house, we were like thrilled, and everybody was like, that's the room that has network. Or we would be leaning out of the window or our balcony to get that network, and we were satisfied with that. Then came a stage where we expected network to be there even while we are traveling in long distance trains, right? And the amplitude of our voice was equivalent to our distance, trying to grab that network. After that, now we are at a stage where we are not satisfied with that. What do we want? We want the same network coverage even on top of Mount Everest. Next, we'll want it on the moon. So that's how expectations are rising. Plus, if you go to see, there are a lot of remote teams these days. Applications are getting more complex and distributed. So our systems need to be more and more resilient than ever because we are releasing so fast. You've seen the agility of your organizations, right? It's almost every few days you're releasing. So that's where we need it. Now, do you think it's a one-time exercise? Can I do click, 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 and it's done? Not at all. It's actually 3 phases. The first phase is to prepare. The second phase is the implementation and your design phase, where you put on your thinking hats and all the architects put their head in. And the third phase is maintaining your system's health and performance. Let me go through this life cycle that you see. The first stage is where you're going to set your objectives and your goals. Now, what does that mean? So the business will do a business impact analysis. They will identify which are the crucial applications, crucial resources which are mission critical. They'll do a risk assessment and identify which are potential threats, how often they can occur, and what is the severity. Based on that, they will identify what we call as your SLOs, service level objectives, and SLAs. Right? So some common ones that you have heard of. Anybody heard of any SLOs in your organization? Yeah? Yes? So any one of them you can name? Correct, yes. Yeah, so she mentioned about running 99.9%, that's availability. That's also a metric. So we have RPOs and RTOs. Ever heard of that? Recovery point objective and recovery time objective. So you'll identify all of these so that you can measure your resilience at the end of the day. Next, once you have all this preparation in place, that's when you're going to start designing. The designing and the implementation phase, there are several techniques. I've just put only a few of these. Okay, so some of the very well-known techniques are planning for redundancy, having extra components, fault tolerance. So if there is a fault in one part of the system, it will not bring down the entire system. You reduce the blast radius, what we call, right? You do not want it to spill over or cascade or impact other parts of the system. Then we also have loose coupling. So ever heard of microservices? I'm sure you would have, right? So what is the basic funda behind that? You're breaking down a large system into individual smaller components. So you're loosely coupling it, so the dependency is less. So individual components can be scaled individually, they can be tested individually, right? So that's called loose coupling. Once you have done all your design and you've put in the best practices, next stage is very important, which a lot of organizations don't do enough of. Test, test, and more of testing. If you have not tested your system, you are just hoping for the best, frankly. Right? So there are many mechanisms that you can adopt for testing your resilience. One of the popular ones is your chaos engineering. Anyone's heard about chaos engineering? What do we do in chaos engineering? Yes, you're inducing or you're disrupting the system purposely. You're inducing faults and disrupting it. You're simulating real-time scenarios to test the vulnerabilities, the gaps of your system. You should do it enough times so you can identify them. So that's chaos engineering. Purposely you are doing experiments. You can have game days. I'm sure several of you must have done game days. So what does game days do? They are basically looking at your incident response. So how does your team respond when an incident happens? Does everybody run helter-skelter, or do you do it in a planned way? Right? So that's what game days do. They look out for your team's responsibilities. They look out for your escalation path. Who should be responsible for what? And if you do it well and enough number of times, you will develop something called as a muscle memory. So as soon as your systems go down, your team will get into action. Right? So that's called game days. You should also induce failures by load testing, stress testing, and many other ways. So this is what is done in your evaluate phase. Thereafter, you have the operate phase. Now, what is this operate phase? So you will do an operational readiness review. What happens over here is you would want to automate as much as possible. We humans are notorious, right? As soon as we come into the picture, things go wrong. Okay, so you are going to try and automate things, remove that human element as much as possible. You will also have ways to monitor the health and your performance of the system. If you don't do that, how will you actually remediate or do an auto recovery, right? You want your systems to automatically do things. Now, if any of you have been on call, right, you don't want to be woken up in the middle of your night while you're dreaming of a Hawaiian holiday to a pager going off, right? You want your systems to automatically heal. So that's where you will be monitoring, you'll be collecting logs, you'll be setting up alarms and notifications. And there are many ways. You can collect traces these days. Traces is the path that your request takes as it's moving through the distributed system. So all those comes under this stage. Obviously, you've gone through this entire phase. you will have a lot of findings, a lot of feedback. You'll pour that feedback and then you'll improve on the cycle again. Great. Now that you have this wonderful plan in place, we spoke about measuring resilience. How will you identify that your organization is on track? You can't do anything without measuring it. So there are also a lot of RPOs and RTOs that organizations will have in place. So recovery point objective is to do with your data loss. So it is the amount of data that your organization can afford to lose or recreate before it can start resuming its normal operations. Okay, and it's measured in hours. So for example, you're taking backups, say at 12 noon and 12 at midnight. Okay, so your RPO is going to be 12 hours. So say at 2 p.m. your systems go down. So at max, you've lost 2 hours worth of data, right? So that's your RPO. RTO is to do with your downtime. In case of mission critical operations and mission critical application, your RTO will be as small as possible. It could be in seconds also. So because the downtime is actually related to your revenue loss, your data loss, and many other losses. Apart from this, these two, RPO and RTO, are used extensively when you're planning for your disaster recovery in a cloud environment. So there are 4 strategies that you see here. From the scale from the left to right, it's increasing in cost. So the first one is in hours. So if you have low priority use cases and applications which are not mission critical, it's okay for you to, recover data slowly. And this is a very low cost effective solution. However, that may not be the case for all your applications. Then you go to the next stage. In pilot light, you will provision a few of your resources. These resources are just in standby. They are not turned on. So they are ideally, I'll say, out of service until they are required. However, your data is in sync. Okay, so your resources are not up and running. So there's going to be a cold start time for that compute to start off or your VM to start off. That is going to be in tens of minutes. Then comes the next stage. In this stage, you have few of your resources which are already running in your recovery site, okay, and a part of your production traffic is reaching there. Okay, so they are warmed up state. This is like your biryani, right? When guests are coming to your house, you would keep your biryani warmed up in low flame so that when they come and they are hungry, you can serve them hot. So in this case also, you are keeping some resources in standby in a recovery site. And as soon as there's going to be a disaster, the entire traffic is going to be directed there and it will scale out that time. Finally, the last one is an active-active scenario where you have a recovery site as well as primary site which are both active and identical. Of course, this is going to be the most expensive of the lot, right? You have identical resources in both places. But in this case, the failover can happen really instantly. So that's nearly zero downtime, nearly zero data loss. But all of these will be decided by the organization based on whether it's a mission critical application or it's a low priority one. Like one of you mentioned, 99.9%, 90%, what is this? This is a measure of high availability. So there's 1/9 of availability that is equal to 90% of uptime. That's about a little more than 36 days in a year that you can tolerate a downtime. A more critical application will usually have 5 nines, so 99.999% uptime, which equates to a little more than 5% downtime. Okay? Apart from these, there are some other KPIs that you see here. The first one is failure rate. So say in the first quarter of the year, you have 20 releases happening. Out of these 20 releases, say 7 of them fail. In the next quarter, you have improved. Say out of the 20, only 5 have failed. So your failure rate is reducing. Okay, so this is to do with failure rate. Scalability. So in certain organizations, during peak times, during seasonal sales, promotions, suddenly there's a surge of traffic. Is your application resilient enough to cater to that? Can it scale? automatically. I don't mean by you humanly going and adding a server. Okay, so that's to measure scalability. Fault tolerance. If you have multiple components in your system, if one component fails, does it bring down the entire system? So for example, in a retail application, just because there is one user registration component which is failing, it should not prevent the other users from shopping, right? So that is to do with fault tolerance. And then we have this 3 M's. These are really crucial. Let me explain it to you diagrammatically. The first one is MTTR, mean time to recovery. As you would have guessed, it is the time that you take from the time that there is a failure to the time that you can resume normal operations. You obviously want to reduce it as much as possible. Then we have MTDD, mean time to detect. Now this will depend upon that operational readiness I told you about. Okay, if you are collecting metrics, if you have logs, if you have traces, you will be really fast in finding the root cause, right? You will be good at troubleshooting. So you will get to minimize it. So this too should be as less as possible. Then finally, mean time between failures. So we want a highly reliable system. We don't want to be just good at fixing things. We don't want it to fail firstly, right? So it is the time from when you resume from the previous failure until the next failure. So you want it to be as long as possible. The longer, the better, right? So these are 3 M's which are really important. Now, we've done all the great planning. Now put on your thinking hats, and we need to think of strategies to build and implement such a robust system. So we'll talk a few techniques. Now, while you're designing for resilience, there are 2 ways you do it. For frequently occurring failures, which are very common, like a server going down, or say transient network, or say there's a lot of load, you will usually try to fix them in the primary region. And they're very common and happens regularly. In case of infrequent kind of failures, like literally the internet going down, or the region going down, or aliens attacking, I don't know what we'll do about that, but in those kind of large scale scenarios, you'll have to have a recovery site. Okay, that's disaster recovery planning. Now, what is the difference between the two? So I'm sure you must be like, yeah, she told us about 2 of them. So as I said, you'll plan for HA or high availability for common failures which have less impact. Okay, so things like transient network issues, a sudden rise in latency or sudden rise in load, whereas disaster recovery is big scale, large impact scenarios. The measurement is also different. In case of high availability, you'll measure it with the number of 9s, which I just showed you earlier. Whereas for disaster recovery, you'll measure using RTOs and RPOs. The mitigation techniques are also different. So in case of high availability, the mitigation will happen in place, in the primary site itself. Either you'll replace the resources from the ones which were failing, or you'll add more capacity if it is a load related issue. Whereas for disaster recovery, you'll have a complete recovery site by itself. So you'll either recover the entire application, or you'll recover data from that recovery site. Okay, so they are different. Now, when you're designing a system for high availability distribution, there are 5 essential features it should have. One is to do with redundancies, having multiple components, or literally having an identical replica of the entire application stack. Then you will have sufficient capacity. Now what does this mean? Meaning you should have sufficient compute, memory, quotas, right? Timely output. It's not just sufficient to just give anything to the user. You should give it in a timely manner, right? There would be some SLAs and SLOs in your organization that you need to respond within a reasonable amount of time. Not only that, it should be functionally correct output. You can't just output anything you want, right? It should be correct. And fault isolation. As I told you earlier, it should not spill over onto other parts of the system. In the absence of any of these 5, you will see there are very common categories of failures which we abbreviate as SEAMs. The S stands for single point of failure. So if you don't have redundancy in place, what's going to happen? There's only a single unit there. If that's gone, it removes everything else, right? So that's a single point of failure. If there is excessive load, that means you do not have sufficient capacity. Okay, you're running out of compute. Probably your servers will stop responding because the CPU utilization is going very high. You'll have out of memory errors because the memory is going really high. Or you might face what we call as throttling, okay, or rejection of requests. If you're not getting timely output and it's taking excessive time, that means there is something wrong with your application. Probably you've not optimized it enough, so it's taking too much time. Or you've included some network components in between, which is adding to the latency. And finally, this is to do with misconfigurations and any bugs and defects. As I said earlier, test, and more test. If you've not conducted reviews, if you've not done your usual unit testing, regression testing, integration testing, there is bound to be some kind of bugs and defects, and you are not going to get the output that you require. What is shared fate? Impacting other systems, impacting other users of your system, because many applications have multiple types of users, so we don't want that to happen. So these are the categories. Now these are several of them. I have just fitted in as much as I could into one slide. So these are some techniques. You can do load balancing, automatic scaling, you can do caching. So very common queries, or if your data is remaining relatively static, you can use caching options. You can do graceful degradation of not so critical modules. Backup and replication. You won't believe how many customers fail to have a backup plan. Backup and replication is really the key and foundation for a resilient architecture. So let me just go through a few of them. Very simple, redundancy. As you know, some of you who've worked on AWS Cloud, every region in AWS has at least 3 availability zones. Now what is the availability zone? An availability zone is made up of 1 or more data centers. They are actually those hosts on which your virtual machines are running, right? So we have at least 3 of them. So say there is a flood, or there is some natural calamity, or somebody pulls the plug, just a malicious attempt. If you've designed well, you would have your servers in the other availability zones, so they are still available. So this is called as redundancy. Anybody can give me a hint? Where do you see failover? Which kind of applications where you're failing from the primary or the master to a secondary? Where do you see it? Yes, disaster recovery, but what kind of? Databases? Yeah, in databases you see that. So it's a very common scenario in databases where there is a standby database which is always in sync, right? So it can fail over. Bulkhead pattern. So this is inspired by designing of ships. So if you see the design of ships, it will be compartmentalized. So what happens is if water seeps into one compartment, it doesn't pull down the entire ship and drown it. Okay? I don't think this was done for Titanic for whatsoever reason. That's why it went down. So what does this really mean? So in a bulkhead pattern, say all your customers or clients are hitting only one service. So if there is one rogue customer, say which is doing like a DDoS attack, it is overwhelming the service. Even the other customers are going to be impacted, right? So what can you do? You can break down the service into service instances. Okay, again here you are trying to do something called as loose coupling, no low dependencies, and you can see that only that service instance will be overwhelmed. The other service instances are not impacted. Okay, so this is a bulkhead pattern. This is very common to our everyday scenario. Say you've got a promotion and you're trying to call your best friend forever, and you're like calling, and you always get that busy tone and they're busy. Okay, so I say, okay, she's busy. You try again, exactly after 2 seconds, right? Again it's busy. And they're like, okay, she probably might be a little occupied. So instead of doing it again after 2 seconds, you give it a 5 minutes gap. So this is a mechanism which we called as retry and back off. Right? So in the client side, we can implement this. This is another mechanism. Now let's go through the evolution of a resilient design. Now 2 is better than 1, 1 is better than 0. Say if you have one server, everything is running hunky-dory, all is fine. Now what if this goes down? Customer or end user is going to have a bad experience. So what you can do is, you can front it with what we call as a load balancer. So the load balancer component is an intelligent component which follows an algorithm, say like a round robin or a weighted pattern where there's a weightage given, and it will distribute the load amongst the target servers. It is so intelligent that it will also do health checks. So what I mean by that is, if say one of the servers, so if one of the servers fails, so the health check will fail, it is smart enough that it will slowly send all the requests to the other server. And if you combine it with a feature which is called as auto scaling, what will happen is the faulty server will also be replaced. So what will happen? Your whole availability and performance will remain the same. Next, what if both the servers go down? That's also possible, right? So if you put all your eggs in one basket in the same availability zone, that could also go down. So what is the next stage? We can have multiple availability zones in the region, and it's distributing between both. So even if one of the availability zones go down, the other one is still available. Now, the scenarios which I showed you, these are common types of failures. Say that is load-induced, sudden surge of request, transient network activity, a rack of servers going down, or just one of your data centers going down. But the more uncommon ones, such as the region going down, the internet going down, your ISP provider going down, natural disasters. In that case, you will have to plan for disaster recovery. So that's when you will have two regions, a primary and a recovery region. Okay, so now you have two regions. The recovery region is inactive, so you're not really sending any traffic there. Everything is happening here nice and fine. Then one day suddenly there's a disruption. What you will do is, you are smart enough, you have replicated your data across the two regions. Okay, so you've kept that ready, up and running. As soon as the disaster happens, you will point your DNS records to the recovery region. So all your requests will now pour into the recovery region, and you saw that it scaled out, right? Previously there was just one instance of the server and one instance of the database. Suddenly it scaled out to cater to that increase in requests. Great. So I'm sure I have equipped you all with sufficient techniques. Okay, so I'm just going to summarize a few of them. So we spoke about load balancing. We spoke about automatically scaling your requests. We also spoke about loose coupling, that is directly related to microservice architecture. We've spoken about having durable storage. So it's essential that you make choices of durable storage such that the data is not lost. Then we also have strategies related to security best practices. Okay, now if you've attended the session earlier today in the morning in the keynote, security is very essential, right? If you are not literally making your systems like a fortress, that could also bring them down. So things like encryption of data, having granular permissions for authentication or authorization, having security in depth, meaning at every layer if you put a secure practice. So these are some of the best practices you should have. Incident management, okay, so how your teams respond. So that's the key, where you should have game days and you should have chaos engineering. And finally, automation and monitoring. If you're not automating and monitoring your systems, you might introduce some human error somewhere down the picture. One more point over here, infrastructure as code. I'm sure a lot of you must have worked on Terraform, CloudFormation. So basically, you are able to build your infrastructure and tear it down in a repeatable, consistent fashion. So you can bring up your environments really quickly, right? So you write it in declarative code. You don't really put it in coding language. So these are some of the strategies. What are your key takeaways here? So I will say your key takeaways are, for designing for failure, you should assume that things will fail, so you design it right from the beginning so that you have redundancy and fault tolerance in place. Automate things as much as possible, reduce that notorious human element wherever possible, and let it recover on its own. Okay, so if you have alarms, notifications in place, which will trigger the automatic recovery, that's the best. And keep testing. Secure your applications. So I highlighted best security practices. Plus, ensure that your servers are patched and maintained and up to date. Monitoring is essential, and it's not just monitoring. You take feedback, adapt, and make changes, and the whole cycle repeats again. Having said that, I hope I was able to give you some guidance and best practices to build resilient and robust system which will stand the test of time and will resist any kind of turbulent or turbulences or any kind of situations that it occurs. If you're interested in some resources, I would suggest that you scan this QR code and you can read up more about resilience on the various cloud platforms. And if you're keen to connect with me, that's my LinkedIn, and I'll be happy to answer any questions if any of you have any. So time's up, but maybe we can take one question if anybody has. Any questions, anyone? Oh, okay. I think they want the QR code.
Can we get the QR code? Console? Yep.
Any questions, anyone? All right, so having said that, thank you very much for being a very attentive and interactive audience. I surely enjoyed my time here. Have a great rest of the afternoon. Thank you so much.
Thank you so much, Parnath. I would request the session chair to facilitate the speaker, please. And can we have her slide also, the speaker slide for the picture? That's right. Yeah, sure.
So, I'm not sure how many of you know, because this is our second innings. Basically, after 12.5 years of working, right? 12.5 years of working gap. This is the second innings, and this is a special day because it's the second anniversary. She actually upskilled herself in AWS, and she's an AWS expert. So if you want to connect, you can connect after this. And she has another speech. I was just asking her, okay, are you fine? Everything is done. I'm preparing for the next speech, which I'm going to give in Pune. So you may be the next person who's doing this. All you have to do is just don't give up. Take the first step. Thank you, Prana, for the wonderful
Thank
session.
you so much, Mahati, for the kind words. Yeah, you can surely connect with me, and I am always out to help the community, so please reach out.
Thank you.